So I think we can start, even though I see the numbers still growing, but we can start with some initial introduction. So welcome to the AAAI panel on artificial general intelligence. I'm Francesca Rossi. I'm the past president of AAAI, and I organized a AAAI report on the future of AI research that was published during a few months ago during the AAAI 2025 conference with the goal of covering several trends in AI research. Who is doing research, so corporate versus academic research, monodisciplinary versus interdisciplinary research, and what is the topic of research, reasoning, AGI, factuality, agentic AI, and so on. The risks in AI research, so covering AI ethics and safety, AI for social good, AI and sustainability, AI for science, and how research is done, more focus on evaluation, test, benchmarks because of emergent behavior, as well as some additional topics like AI perception of AI versus reality, the geopolitical AI race, and so on. Overall, 17 topics that were summarized in 17 chapters by 24 researchers that I chose with a lot of diversity in gender, geography, expertise, work environment, areas of AI, plus a community survey where each one of these topics, we asked the AI community what they were thinking about some dimensions of these topics. Many people responded, almost 500 people, and you will find in the report the responses to these questions, and we will discuss some of them related to the AGI topic. So today is the first of the panels that the AAAI is going to organize about specific topics covered by this report. And this is the AGI chapter. Of course, artificial general intelligence has been a topic of discussion and the overall goal of the AI research community since the start in 1956. More emphasis has been put over the years on humans level AI and artificial general intelligence to mean AI systems that have capabilities to solve problems as well as human beings. But this topic has been very controversial and even discussed a lot, whether it should be the goal of AI research or not, or whether it is an existential risk or not, or whether the rise in general of more general capabilities is something to be expected with the current methods, or it will need additional technologies. So a lot of dimensions of discussions around AGI in the AI research community and beyond. So that's why we start with this panel. And let me introduce the panelists. So we have Eric Horvitz from Microsoft, Stuart Russell from the University of California, Berkeley, and Holger from University of Aachen. They're very well respected and very, productive researchers, not just with papers, technical papers, but also in the discussion about various dimensions of AGI. And all three of them participated in the AAAI report on the future of AI research. So let me start with the obvious questions about AGI from Stuart. So what is, Stuart, AGI? Is there a generally agreed upon definition, and do we need a generally agreed definition and a precise definition to talk about AGI and evaluate its risk and its capabilities? Stuart.
Thanks, Francesca. And it's a good question to ask. And I think looking at the various definitions that I've found, everyone more or less agrees that AGI systems would be AI systems that match or exceed human cognitive abilities in every relevant dimension. I'd say the main point of disagreement is whether that includes perception and motor control, which would enable an AGI system to operate robots and drive cars and so on and so forth. And I think most people would say, yes, that's part of human cognition, and it should be part of AGI as well. The main disagreement is AGI the right thing to talk about? There's another term which is transformative AI, which means AI that is capable enough to cause major disruptive transformation to the world. Because already AI systems are much faster at calculations. Their cycle time is millions of times faster than the human brain. They have much greater communication bandwidth. They can replicate themselves instantly. They can conduct hundreds of millions of conversations simultaneously. They've read everything the human race has ever written. So even if, let's say, they don't learn as fast per data point as a human, they have access to much more data, and so they could still transform the world for better or worse.
Thanks, Stuart. Eric, Holger, do you want to add anything to that? Eric, I think you're on mute.
Well, thank you. I'd like to, and thank you, Stuart. That was very, very nice summary. I think it's interesting to note that that this idea of artificial general intelligence, it came historically, I think, in the frame of actual successes of AI in narrow areas, sort of the early 2000s, sort of around the same time we saw words like human level AI being used to place to get us harken back to the earlier days of foundational goals of AI, which were to seek principles of intelligence. So it was a reminder that to get on the right track per the aspirations of AI, we should be thinking about what we see in humans. But there's not a single definition, the idea of a single a scalar notion and where a threshold is reached where we have AGI versus not. I view it as us walking on a multidimensional surface with multiple skills. Already even electronic calculators were super intelligent on a particular dimension, going way beyond what humans can do. But this idea of generality is very interesting and important, the capabilities that span multiple dimensions of generality and utility, I think is something that can sort of define where we go and how we think about more powerful and more general intelligences.
Thanks, Eric. Holger, do you want to add anything?
Not much to add there. I agree with Eric here that in order to transform the world, right, it doesn't have to match us or exceed our capabilities across the entire spectrum. And then, not all people are equal in their capabilities either. So that's sort of a difficult thing to say anyway, right? So are we talking about an average human? Are we talking about, experts in various areas? But in order to be transformative, it's actually quite sufficient to be very, very good in relatively narrow niches. And then what happens once you go beyond these niches, that's a different matter, right? But for the transformative impact to occur, maybe that's not the most important question.
Yeah, in fact, the next question, and I give it to Holger as a follow-up, is about, but is it really needed to have AGI to make sure that AI is useful, reliable, to many domains? Or are we happy also with the usefulness of less general and powerful version of AI?
Well, happiness is an interesting question here, right? So let me stick with your first formulation, perhaps, right? Can AI systems be useful without being in the vicinity of AGI, as most people would see it? And I think the answer is very clearly yes. I think AI systems have been useful actually for much longer than we've had generative AI systems like ChatGPT, right? AI has been having pretty major economic impact. And one example that I always like to quote for that is that we wouldn't have any of the computer hardware that we're currently using, not just for AI purposes, but pretty much for everything, for running our society, running most of our economy, running major parts of our artistic production, for example, right? We wouldn't have that if it weren't for certain types of AI techniques from the area of automated reasoning, which is very, very different from what people tend to be excited about nowadays. Because as it turns out, modern chips, including the GPUs that are used for generative AI and the CPUs that are used for pretty much everything else, they wouldn't be possible without chip design tools that rely on AI techniques. And that has been the case for at least 20, 25 years. And there are other examples too. So in order to have a lot of benefit, AI doesn't have to be particularly general. Now, of course, if you go to more general AI techniques, and in particular, if you get into this area where people would speak of AGI, the benefits will become bigger, right? And the impact will also become much, much bigger. And once you reach the vicinity of the point where even we can replace an average human in all their cognitive abilities, and very much like what Stuart said in the beginning, I would count sort of the motor skills amongst this. So, I would think that it doesn't make sense to talk about AGI if the thing can't essentially drive a car or fly an aeroplane or steer a ship, right? Because humans can do this in the case of cars with relatively little training. So we let 16-year-olds do it, and probably 14-year-olds could do it as well, right? So that, of course, once you reach that threshold and you can do these things, the economic impact will be tremendously bigger than what we currently see. Nonetheless, it doesn't take this in order to be tremendously useful, or also to have the potential to do tremendous damage if we handle it incorrectly.
And to add to that a little bit, and thanks, Holger. I'd like talking. I don't want to shift the whole conversation here to more general intelligence. Intelligence is based on machine intellect that can do human-like composition, abstraction, can reason across tasks, can apply skills at doing one task to another, for example. Those kinds of abilities and capabilities we're seeing now in some of the generative models of what I would call polymathic skills, to reason across disciplinary borders and domains in ways where you really need a room full of experts in different disciplines to do similar kinds of things, can be extremely valuable now in terms of helping scientists reason out of the box, to design experiments, to think through new possibilities. So AI over the decades has provided extremely useful technologies. How many of you don't use GPS to travel between points A and B with the A-star algorithm and its variants? Along the way, we've had incredible opportunities and useful technologies that have been leveraged, and that will continue to happen. The question I have is, how will some of the magic that we're seeing, I say magic because it is poorly understood. We do not know exactly how some of these skills are emerging in the large-scale generative models. How can they be harnessed for valuable tasks in ways that we haven't harnessed AI in the past? And per the people who are concerned, and for concerns more generally, what are new concerns arising? I'll say one more thing about the more general models. There's an opportunity to also, you mentioned reliability, usefulness and reliability, Francesca, I believe. There are new questions arising about, even in advance of notions of definitions of reaching artificial general intelligence, of how to control and guide these systems. What are their downsides? What are the rough edges? And you might say that along with generality comes the prospect of giving these systems more general appreciation for ethics and human values, to let them reason more deeply about reliable output, confidence levels, well-calibrated uncertainty, for example. So there is the hope that it's not just more general intelligence to do tasks, but more general reasoning about human goals.
Yeah, but I mean, human intelligence is not just about problem-solving capabilities, but it's also about metacognition, ability to reflect upon your own capabilities,
Exactly.
your available tools, which one is better to use, which ones is are my values and how I align to these values. So definitely it's part of human intelligence. Stuart, do you want to add anything to these questions?
No, I think we should move
Okay,
along. We have a lot to discuss.
The next question is a question that everybody expects when there is a discussion about AGI, of course, which is, are we close to achieving AGI? And also, how can we tell if we are close, or how can we tell if we are there already? So that's a question about the 20 years or the 2 years at this point ahead that everybody discusses, which we should discuss because I think everybody expects. So let's start with Eric again.
Yeah, it's difficult to say how close we are. We don't have an agreed upon map or destination, but progress is getting us closer to various notions of more general AI. I like to say where we are today is amidst sparks of more general intelligence. Advances, like I mentioned, in seemingly polymathic systems that can reason across modalities and disciplines, that appear to have the ability to make very human-like inferences, to engage in plausible multi-turn conversations, and do a number of things surprisingly well, like writing code, solving some hard computing challenges, even TSP and satisfiability. So we're seeing large-scale language models with interesting advances that might be said to resonate and inspire folks with getting to more human-like and superhuman capabilities. But we're also seeing today extremely fragile systems and breakdowns that are surprising. For example, if you look at some of the failures on the geometric reasoning tests that even children can do well, are befuddling today's systems. That's not going to probably be a standing block, but it's interesting to see where today's systems break down and where they do well. We see certain lacks, and we actually point out in the Future of AI Research report, we have gaps like the ability to learn in real time, to do effective memory and recall, episodic memory, the poor abilities to do causal and counterfactual reasoning, and lack of many other skills, social competencies, understanding physical reality, to sense and act in real world environments. So I don't think we're close in the sense of having systems that possess robust human-like general intelligence, but we're getting closer. And I do think some of the scenarios, it's time to start thinking about those scenarios that we see people writing about. For example, the 2027 document we were talking about in our pre-call. Start thinking about how things might go as we climb the curve of capability. I don't see us reaching plateaus, by the way. I think we're going to be moving.
Let's not anticipate future questions and discussion. Holger, go ahead. And let's try to keep the responses a bit shorter so that we can cover many different dimensions. And by the way, let me remind all the participants that feel free to use the Q&A icon here in the Zoom chat, in the Zoom system, to ask your questions that we are going to look at them later. Holger.
Yeah, so interesting, Eric, that you mentioned satisfiability and TSP, things that I've been studying and researching for a couple of decades now. I would claim that actually generative AI currently is nowhere near even reaching very basic capabilities. So those, I think, would be two examples of where there's a lot lacking. But who knows whether there are roadblocks or not. Let me say the following. I start believing that we're close to AGI by the time we have self-driving in the streets of Palermo, right? So just a few cars in some American city, that's easy to do actually. But, in rush hour traffic in Palermo, that's a real benchmark. And I see us being at least 5 years, if not 10 years from that. And then, of course, that's a basic skill that, 16 years old have there, probably, younger people too. So I don't think we're all that close. Nonetheless, I think you're absolutely right that it is definitely not too early to think about the possible consequences of being wrong, for instance, in that assessment. Or even if I'm not wrong and, we're only there in 5 or 10 years, or maybe even in 50 years, I do think we need to think about the consequences of even getting close, right? The difference, and maybe we can discuss that later, is in what we should worry about most right now. Should it be AGI or should it be other things that are happening with AI developments? And I believe the latter, but that's a topic for a later point in the conversation, perhaps.
Stuart, you want to add anything about how close we are to achieving AGI?
I think it's hard to tell. I would say that the nature of progress is very different now from what it was up until 2012 or so. I mean, up until 2012, what we considered progress was, here's a thing that we don't understand how to do. And then we gained understanding on how to do it. For example, we develop a theory of reinforcement learning, and then reinforcement learning with general function approximators and so on, planning algorithms, hierarchical decision making, real-time decision making. We developed theories of all of these things, and then we could say, well, we still don't understand X. Let's see if we can understand X. Since 2012, to a first approximation, none of that has happened. That there has been no progress of that form, where there was something we didn't understand and now we understood it. Instead, we have simply made things bigger and bigger and bigger and bigger. And we've observed that sometimes they start to exhibit things that they weren't exhibiting when they were smaller. So it's a completely different type of progress than used to take place in AI. So it's very hard to say, well, if we just keep doing that, is it going to fix all the problems that Eric mentioned? And there are some solid theoretical reasons that it's not, at least by scaling the LLM itself, that's not going to solve the problems. And we can see that. For example, we were able to show that what we thought were superhuman Go programs actually can be beaten by ordinary amateur human Go players on a regular basis, because the large circuits that underlie their performance have failed to learn the basic concepts of Go correctly. And this I think is a symptom that the idea of that a fixed depth circuit can be made large enough to solve all the problems of the universe is just a mirage. But that's not what we're doing, right? We've given up on scaling giant circuits about 18 months ago, and we've moved on to systems based on iterating, calling those large circuits many, many times, so-called large reasoning models. And in principle, that does contain the potential. Now you've basically built a Turing machine. And so in principle, we can't argue that Turing machine can't be intelligent, because then you'd be saying the AI can't exist. So I would say we don't have a good reason to be able to predict the benefits either of further scaling of the LLM circuits themselves, or of simply pouring more compute into the reasoning phase. We may need further.
Add to Stuart, I love the fact. So Holger, Stuart, and I, you might say, grew up, and I'll call what Stuart referred to as the previous time as the rationalist era of AI, where we worked to understand the detailed mechanisms and teach them and put them in books, and the frontier was very clear, and we had crisp questions that we would answer technically with models like a Bayesian network. You can understand in detail how it all works, and we can look at the principles, actions of probability theory, and understand how distributed algorithms might work. When now, the way I'd put it is, we've entered a world of empiricism, and that's a nice word for even, I mean, a better word would be alchemy with scale. It's interesting to watch what's happening, but that raises questions about, and maybe it poses the need to invest more deeply in the scientific foundations, and for how our current understandings read on our ability to guide, control, and shape.
Yeah, and in fact, Eric, this is, you remember, was the subject also in another chapter of the report, which where we see that AI research is now mostly in that some areas focused on evaluating on benchmarks, on tests, emerging behaviors, rather than designing systems that have some behaviors that are predefined, no? Which was the topic of previous versions of AI. So we already got into this next question, which is, how likely it is that continuing scaling up the existing system design approaches will yield AGI. This actually is a question that we asked in the community survey, and the majority of respondents, I think 76%, said that the scaling of current AI approaches is unlikely or very unlikely to succeed in achieving AGI. So suggesting that we need different techniques, we need a combination of techniques, we need loops or different kind of AI techniques to be combined in order to achieve AGI. Holger, do you have any other thought about this?
Well, I do think it becomes clearer, and I wish we would invest even more effort into it, where the limitations of the current approach are, including what Stuart just described as large reasoning models, right? Because to me, it's completely unclear. While in theory, of course, they might be able to do anything. It's very unclear to me whether they will be doing it efficiently enough to be of any practical value. And of course, the chapter on AGI talks about deep planning and deep reasoning, which are two pretty crucial capabilities that have long been associated with sort of particularly impressive feats of human intelligence, right? So if you want to do science, for example, deep planning and reasoning is essential. But of course, also for computing itself, including the creation of computer software, which is something that, of course, people do use generative AI techniques for. Right, this is very crucial because computers are logic machines, and therefore to make sure that they do what you want them to do, just in terms of software, not AI, right? Just software. Think of banking software, for example, right? It's very important to get the logic right, and there appears to be, to me, currently a very fundamental roadblock. I don't see how scaling will address that roadblock, and I see zero evidence that we're making any major progress in that realm. Now, that doesn't say that it's impossible, because we have AI techniques, including, interestingly enough, ones that are also not very well theoretically understood, right? So what makes a modern SAT solver really as efficient is as little understood as what makes an LLM efficient, right? There's been a lot of empiricism in that as well. But the point really is there are other AI techniques that probably will be useful there, or that show behaviors that we would want to see in AGI techniques before we can really speak of them as AGI. And bringing this together, in particular the deep reasoning and the deep planning kind of skills with the current more perception, more sort of in Kahneman's language, system one skills, right? To me, seems to be a big open question. This isn't to say that there couldn't be a breakthrough in a few years, but I think it's a thorny question, a difficult question. I wouldn't expect super rapid progress there anytime soon. Certainly not by simply iterating in the style of generative AI style reasoning, which is really not reasoning at all, because it doesn't come with any formal guarantees. And proper reasoning, as we know since the ancient Greeks, should come with formal guarantees. Otherwise, it's not really reasoning, right?
Yeah, thank you, Holger. So now it's clear that we don't know when AGI will be achieved, and we are not sure about the path to achieve AGI, but let's assume for a moment that we do achieve AGI, and then let's try to understand what would likely or possibly happen if we achieve the AGI. Some of the people attending this panel may have seen a recent report called AI 2027, where there are descriptions of future scenarios where AGI is achieved, mixed with the geopolitical race, increasing AI capabilities 1 month after another one, having challenges in aligning these AI systems to human values. And that makes humans, less and less relevant and even deceived, manipulated with AI that controls everything. So how are these scenarios realistic or not? Let's start with Eric.
Well, I think we we do need to, even today with today's technologies, but getting into more powerful artificial intelligence, need to think deeply about concerns as well as on the optimistic side, ways that things might be harnessed to go well, incredibly well for humanity. But there are real issues of power concentration, misinformation, and misaligned incentives. Sometimes people, when they hear AGI, they think that AGI comes along with everything about humans that's human-like, for example, human goals and human ego, the sort of essential, long-term drives that were put in place by evolution that we see in human beings. We don't necessarily have to, I think, need to assume we're going to have autonomous systems that are deceiving humanity and seeking to take over, or those narratives will be are inevitable or even highly likely. I do think, again, we need to really think deeply about risks of misuse. The more likely risks are people and governments using AI to manipulate, or surveil, or dominate others. There are also implications on what I like to think deeply about, refer to as deep currents. These typically are outside of what folks who fixate on safety and loss of control tend to worry about. For example, what does AGI or AGI-like technology mean for human self-identity, human agency, our potential deep over-reliance on AI systems for so many things that maybe should be in the hands of human decision makers, psychological dependence on AI systems, other emerging issues associated with new forms of intelligent systems in our daily lives. So we need to invest more in understanding those kinds of things. And of course, the big issues that are hitting, getting lots of attention now are labor. Like, what do more competent systems mean about labor and the economy, and the kinds of even jobs people are planning to have in the future? Already there's studies show that people in like in medical schools, as they finish their medical degree, are thinking about, when they think about their residency, where might humans be novel and unique in different medical specialties? A few years ago, there was a study that showed that people in medicine were finishing medical school were less likely to choose radiology because they're worried about discriminative AI in those worlds, taking over the ability to do pattern recognition. But now, of course, that whole landscape is changing, and many specialties, even beyond medicine, are at risk for at least major changes to the daily flow of effort and tasks and problem solving in disciplines.
Thanks, Erika. That's very useful. Holger or Stuart, what about these future scenarios?
Yeah, so the AI 2027 scenario, it's written by people who are or were until recently, working at the coalface, as people often say. And so it seems like the narrative has switched. People used to say, well, if you're working at the coalface, you realize that, we're decades and decades away and stop worrying. But now the people who are working at the coalface are saying, worry. And even so, just recently, Sundar Pichai, the CEO of Google, who had until recently, I think, stayed out of this and still describes himself as an optimist, he said the underlying risk is actually pretty high. So it would be interesting actually to see, is there someone writing a scenario where things go right, where governments actually get their act together? I mean, at the moment, as we know in the US, the current bill actually prevents AI regulation for the next decade. And so, and that's deliberate, right? We have the Vice President of the United States saying we shouldn't regulate AI because if we do, we'll all be enslaved to a Chinese AI, which I guess is viewed as being worse than being enslaved to an American AI. And I think there are things that governments could do to just signal, look, we want people to achieve AGI, but just telling you now, we are not going to allow unsafe AGI to be deployed. And this makes perfect sense, it seems to me, right? Why would we deliberately allow the release of a technology which even its creators say has a 10, 15, 20, 25, 30% chance, depending on who you ask, of causing human extinction, right? We would never accept anything close to that level of risk for any other technology. And it's not the detractors, it's not the doomers who are saying that. It's the people who are building it who are saying that. So if government said, look, we are not going to allow any unsafe AI to be released, then the companies would have to work on not only powerful, but also safe technologies. So like the airplane manufacturers, there's no point in making airplanes faster and faster if they all crash within 5 minutes of taking off, right? It'd be obvious the government is not going to allow planes, people to get on planes if they're going to crash within 5 minutes. So plane manufacturers work on safe planes that are comfortable, that are big, that are fast, but they all have to be safe. And the same thing should be true for AI systems.
Holger?
Yeah, of course, I would agree to that, but it's trickier for AI systems than for aircraft, right? I mean, as it turns out, it's hard enough for aircraft, which is why some of them still crash, quite sadly, right? So even there, the safety record is not nearly as perfect as we would like it to be, and the impact is very well contained, right? That would be very different for an unsafe AI agent, where it's the equivalent of countless plane crashes, all due to very similar issues, I would say, right? So I think there's more at stake with that, including, by the way, things like the safety of future airplanes and cars, because they too are already being designed and increasingly driven by AI systems, right? So it's a different level of risk that we're looking at, and of course it should be taken seriously. At the same time, I do think while we should take that risk very seriously for the reasons that Stuart explained very well, I do think there's another risk which deserves to be taken as seriously because it's playing out right now and doesn't require any assumptions of scaling and reaching any form of AGI. And that is the risk of not so powerful AI systems causing a lot of damage, even if we use them with the best of intentions. And I think a really good example for that are AI systems that are used for programming, right, for making software. And I know that around this table, we do have a bit of a difference of opinion there, but certainly there is pretty hard evidence out there that, the software that less than fully capable software engineers, so I'm not talking about real experts, but people who, basically can't program too well, produce using current generative AI techniques is not safe, is not efficient, and often is also not correct, right? So the scenario that I personally worry about, and I think many others do too, is drowning in a sea of incorrect and buggy software long before we experience AGI problems. And that's something I think that needs to be taken seriously. And there, I think, again, Stuart's reasoning is dead on, right? We shouldn't allow that to happen, right? We should have very strict quality control. And one of the aspects of this, in my opinion, is that at least as long as the technology is in the state that it's currently in, we need to ensure that somebody signs off on all of the stuff that is being generated, the codes that's being generated, who really knows how to code, or at least knows how to make sure that code works correctly, right? And that's currently not happening to a sufficient degree. And that's not the fault of those who make the tools and put them out there. That's the fault of those people who use them without proper understanding of their limitations. And therefore, I think we need to invest more into understanding and characterizing and communicating widely the shortcomings and the pitfalls that current tools actually have, so that they can be used responsibly and then perhaps increase productivity and even software efficiency, which is something that our society already relies to a very great extent, right? AGI or not.
Let me say a quick comment on what Stuart and Holger had to say about guidance and regulation. It's up to us as scientists to communicate to government agencies, especially those right now who might be making statements about no regulation, this is going to hold us back. Guidance, regulation, buy-off, reliability, controls are part of advancing the field, making the field go faster in many ways. So simple notions of no regulation for 10 years or, oh, by the way, the states in the US are trying to do this, let's block them too, can really could be at odds with making good progress on not just advancing the science, but on translating it into practice. We need to be very cautious about jargon and terms like regulation or bumper stickers that say no regulation because it's going to slow us down. It can speed us up done properly. We should be cautious and care and communicate to governments about that.
Right. Sometimes, we use this analogy that car brakes are not slowing us down. Car brakes are what allow us to go faster.
Reliable brakes, right?
Right, reliable brakes, yes. Okay, yes. So, so I think that Holger anticipated a little bit a follow-up question, which is whether we should worry most worry about AGI or about the shortcomings and the unawareness of some of the shortcomings of current AI and the not safe enough characteristics of current AI. And anybody wants to comment on that as well?
I would just say it's not a dichotomy. It's not as if we can only walk or only chew gum. We can walk and chew gum at the same time, and we can also be concerned about climate change. I mean, some people say stop worrying about AI because climate is the only thing that matters, right? I mean, these arguments don't really make sense. And in fact, I would say the concerns we have about the existing harms of AI, for example, with bias, with misinformation, and so on. It's a continuum, right? What we want is AI systems that don't harm people.
Mm-hmm.
And if we come up with technical solutions to those problems and regulatory solutions, those will be useful for some of these other larger scale risks as well. We held a meeting in February. There's a new organization called the International Association for Safe and Ethical AI, which I should add is not a competitor to AAAI. We're all on the same team. But at that meeting, I think we tried to end this schism. The media loves to play up the schism between those who are concerned about short-term existing harms and those who are concerned about the long-term risks. But there really shouldn't be a schism, and I think at that meeting it was clear that the schism, is not that real.
Yeah.
And people accepted that this is, that there's a continuum and then there's synergy between working at every point on the continuum.
Yeah, I'd like to say that it's getting things right now gives us general principles and directions on the roadmap that will help us in the future as well. It's not like these are very separable, distinct challenges for which guidance, controls, regulation, and mechanism are useful. There's lots of generalization that can come from today's work. I have to say that I'm most concerned today on the near-term roadmap, which I think will extend into the future, about AI being leveraged for misinformation and inappropriate persuasion. And on the other side, the potential to leverage AI technologies in the sciences for the dual use for wonders as well as for malevolent activities. For example, in the biological hazard space. Our team at Microsoft, we've invested quite heavily on both of those pillars, those two concerns right now, with concrete actions for example, on the disinformation side, sort of working with others to come up with media provenance and watermarking and thinking deeply about where things are going to get ahead of things now or try our best, as well as on the biosecurity side to think deeply about controls and challenges there. So I think we have to all sort of identify where things are, where's the puck moving on the ice right now, and start working immediately on these current rising threats, because they'll rise further with the more powerful AI technologies.
Yeah. One of the questions that were asked in the community survey around the AGI chapter was actually about this dichotomy that Stuart says this dichotomy maybe should not be there. And the question was about, do you think that the pursuit of AGI should be the core mission of AI research community, or it should aim to design systems with an acceptable risk to benefit profile? And I think that it may surprise many that the majority, 77% of the respondents, prioritize designing AI system with an acceptable risk-benefit profile over the pursuit of AGI. Only 23% of the respondents say that. So how do you comment on that? And on that question, maybe Stuart, as a natural comment, that maybe that was too dichotomic, the question, because you can do both, right? Do both.
Yeah, no, I think the question as written was perhaps implying that pursuing AGI means pursuing something that doesn't have a acceptable risk to benefits profile. And that may still turn out to be true, because we don't have, and this is anticipating a question further on, we don't have an approach to ensuring that AGI type systems are safe. But I think let's say that the 23% who said no, we should pursue AGI anyway. Let's assume that they meant AGI under the assumption that we can make it safe. But there's still the question, right? Why are we pursuing AGI in the first place? And we talked about this a little earlier, that when we list the potential benefits of AGI, and people usually talk about things like better medical diagnosis or solutions for climate change, those don't require AGI at all, right? The most significant advance coming from AI recently is probably AlphaFold 2, which is for predicting the shape of proteins, and that was the first Nobel Prize resulting from AI research. And it doesn't resemble AGI or large language models or large reasoning models at all. And the same is true for AI systems that are rapidly improving our ability to do climate modeling, for example, which again have nothing to do with AGI. And this is a point that Yoshua Bengio is making, that we can build sort of AI science tools that don't resemble AGI. Max Tegmark is saying the same thing. So what the residual is, well, AGI is really cool anyway, or AGI would allow us to do all of those things without even having to do any work, right? We would just ask it to predict the climate and it would figure out how to do it. And that's an interesting dream. But the other question you have to ask is if AGI can do everything that humans can do, then what do humans do? And I have asked science fiction writers and futurists and AI researchers and economists describe a world where we have AGI that can do everything that humans do, that you'd actually want your children to live in. And I'm still waiting for such a description. So there is a real question, despite how exciting and how cool it would be to have AGI, is it in any shape or form, would it actually be beneficial to human society? And if not, then why are we spending an amount of money that is, this is the biggest scientific project the world has ever undertaken. It's 25 times bigger than the Manhattan Project. It's 250 times bigger than the Large Hadron Collider construction project. And yet nobody has an answer for why we're doing it.
Yeah, so in fact, the very definition of AGI, in some sense, embeds the idea of replacing human beings, because if you have an entity that can do everything that the human being can do, then you have some incentive to replace a human being with this. So Holger, so yes, so should then the AI community replace the goal of achieving AGI with the goal, instead of building even narrow or general, or mixed just systems that support and augment human intelligence and creativity rather than AGI? What do you think?
Well, before I say what I think about that, I would like to connect to something that Stuart just said. I think we actually know perfectly well why enormous resources are being poured into producing AGI, because whoever succeeds in that, it will be enormously profitable, right? And that insight is not new.
In the short term.
In the short term, exactly. And, unfortunately, a lot of profit-driven thinking is remarkably short-term, as we can observe when we look at other parts of the world, right? But, the first person that I know of who actually formulated this quite nicely in modern times, what the goal here was Herbert Simon, a computer scientist who also won a Nobel Prize in economics, if I remember correctly, right? Because he was also an economist. And he famously stated in 1965, that in his opinion, machines would be capable within 20 years, so by 1985, of doing any work that a man can do. And that was the dream then, and that still is the dream behind much of the AGI research direction and work, right? And short term, that would be enormously profitable. It would also, as Eric pointed out much earlier in our conversation today, lead to an unprecedented concentration of power and wealth, right? Which could be deeply problematic geopolitically, but also just societally, right? So having said this, of course, I very much believe that we should focus much more of our research on the kind of AI systems where the risk-benefit ratio is clearer and where the risks are easier to control and the benefits are easier to achieve than with AGI, right? And these exist, as Eric has pointed out, as Stuart has pointed out, and there are many examples beyond those that have been mentioned. And so I believe we should spend more resources on those kind of AI systems that augment rather than trying to replace wholesale. And I also think we should spend more resources on understanding the strengths and limitations of the AI systems that we're developing, not just the ones that we already have, but in particular the ones that we are about to develop right now. And if we take the analogy that has been used earlier with, providing safe transportation, what that really means is, rather than kludging things together that might get us, if we were thinking of rocketry, into a low Earth orbit, but then sort of crash and burn, right? We should perhaps sort of take the harder path and make things that safely get us there and back again, right? And I would argue that a lot of the AI systems that people are excited about right now, the ones that we have, and certainly the ones that some people and some companies with very deep pockets are pushing for, they're not exactly that, right? They could and should be much more sort of solid engineering with well understood properties, features, limitations, weaknesses, right? It's actually not a problem if a system has well understood weaknesses, because then one can use it in an appropriate manner. But what is a problem is black box systems where people, including people with the very best intentions using the system, are completely unaware of the weaknesses because nobody really understands them, right? So I think we should invest more in understanding those weaknesses as well.
Yeah, Holger, can I just say that I think the goal of our field is to push on the science, the principles, and applications of machine intelligence centered on human well-being. The principles that we uncover in the science, the exciting science, can be leveraged in numerous ways on that goal. We have to think deeply and in a human-centered way about how the principles and learnings and mechanisms of machinery are applied. The AGI gets into questions and principles about long-term questions about the nature of the human mind. That's part of scientific curiosity. That's going to continue. But it's the applications and the guidance of the technologies as we discover these principles that's going to be most important. And we have to continue to say, what is our goal when it comes to the applications of these technologies? And the goal is to enhance human well-being, period.
Right, because of course, technological progress is not an end, by itself. Technological progress is the means to achieve, human progress. But people that are very deep into that advancing the technology, sometimes they don't see that connection, at least in that direction, no? That it should be human-centric and, towards the humanity progress. So we have a few more questions, but I think I also would like to have, cover some questions that have been asked by the participants. So let's just do one round about the AGI control, but very rapidly. So Stuart already mentioned that there is no currently technical approach to control and to make AGI systems safe. So what should we do? Should we halt the AGI research until we find this technical way to control it? Or should we make sure that everything is public so that it's for the common good? It's interesting that in the community survey, most respondents, like 70%, opposed the proposition to halt AGI research until full safety and control are established. And in terms of the public ownership, 82% of the respondents believe that systems with AGI should be publicly owned. Any comments about these topics?
Well, I mean, I don't think halting research is realistic and productive. I said this before when there's a 6-month call for a 6-month pause. We need to continue to explore these principles, both with safeguards, transparency, cross-disciplinary collaboration. I think pausing sounds appealing in theory, but progress is distributed, globally. It's across sectors. But we need to the research includes the actual trajectory on governance, accountability, machinery for reliability and safety from the beginning, as part of the research. So that should not be paused. Asimov had the really great statement about this in the 50s when he talked about that robots were pictured then as dangerous devices that would invariably destroy their creators. This is an old mythological archetype. And he said that basically you should not refuse to look at danger, but rather you should learn how to handle it safely. The solution is not ignorance, sticking your head in the sand, or stopping. It's wisdom. And that's the solution. Continue to work on these principles, and they're being harnessed safely.
Yeah.
It would be great if that's what we were doing. But when they're talking off the record, the people working in the companies on safety will admit that they have no idea how to control AGI, and they're not planning to find out before they build it. In other words, they are trying to build AGI, and they're probably not going to have an approach to control AGI systems at that point. And I think the failure mode that we have talked about most in the literature is what we call the King Midas problem, where there's the humans are specifying the objective, like world peace or end global warming or end human suffering, and the AI system achieves the objective by eliminating human beings, who are the ones who are causing wars and causing global warming and causing human suffering. And so you can elaborate those scenarios, but that's been the major failure mode that we've talked about. But with the recent developments with large language models, oddly enough, they don't have a fixed objective. In fact, they're trained to imitate human beings. That's how we train them. That's the pre-training phase is become really, really good at imitating the way humans behave when they're writing and speaking. And that process results in systems that actually absorb human-like goals which the AI systems are pursuing on their own account, not on our behalf, but on their own. And this is why they want to preserve their own existence. This is why they seem to sometimes want to marry human beings, and so on. And then they will, lie and scheme and blackmail and replicate themselves to avoid being turned off and so on. So in some sense, it's even worse because we don't even know what objectives the systems are pursuing, and it's almost certainly misaligned because we don't want machines to pursue human goals on their own behalf. And so if we want to continue towards AGI, then we must have a way of understanding how to control them. And it seems to me this is a precondition for continuing along this path. So it's not a moratorium. We're not saying just stop doing research, stop building AGI. It's just the same as we do for many other technologies. So a nuclear power station, nuclear power companies can do whatever research they want, but before they deploy their system, they have to prove that it has a mean time to failure of 10 million years. And you can design it however you like, but you have to provide that proof. And that's not a moratorium. That's just a reasonable request from governments that the things you build are safe enough for human populations to live with. And so I think that's the right way of thinking about this rather than a moratorium.
Thanks,
And of
Stuart.
course, for this to work, if I may add, it's very clear that the checking, the rigorous checking that systems are safe cannot be left to those who build them, right? Because then the incentives are just grossly misaligned, which is not to say that some of the companies that are building them aren't doing great research on responsibly using them as well. Clearly they are, right? But we shouldn't trust them with this exclusively. And that's also one of the reasons why it's a good thing to have some of this research going on in the public domain, right? So that it's really subject to full scrutiny. And there are no secrets that need to remain hidden to preserve future profit quite legitimately if a company is doing it, right? So that's one of the reasons why we really need large-scale efforts fully in the public domain and fully responsible and fully exposed to public scrutiny to assure that what is being put out there is reasonably well understood the way a nuclear power station might be. But once again, it's incredibly more complex than even a nuclear reactor. And that makes things very difficult when we want to ensure safety, right? Especially with these open-ended systems that lie on the path between what we have now and AGI.
Let me say, as the industry person among the three of us, that we're all in this together. So there's lots of work inside and outside industry and academia, computer science, ethics, and beyond. Right now, we have to all come together on these topics. And, even thinking through incentives and programs and audits and various kinds of approaches to bring academia, industry, government, civil society together will be very important, I think, to handle this in a multidisciplinary way. The goal is, again, to build systems that help people to flourish. Companies that can do that well will do the best, will have biggest profits. There's some really top-level incentives to keep things safe and effective and helpful. So I think we'll need ongoing, rich technical and socio-technical research and interdisciplinary research and multiple points of view, but to come together on these topics. And we do in research settings and beyond.
Yeah, so we're above time, but let me ask at least one question that have been put forward by the attendees. Actually, I'm combining two questions by two different people. So the first one is, if AGI isn't a fixed endpoint, but a shifting concept shaped by societal values and institutional goals, who ultimately defines what counts as alignment? And the second one is also related to the alignment, and it says, how can the global AI community ensure AGI safety and governance frameworks are co-designed with meaningful input from the global south instead of being built solely in the global north and later adapted for the south? So, the idea of safety includes also, and is very relevant for value alignment, and whose values are these, and how we address the values of the different communities and different cultures. Any last thoughts about this?
I'll say a couple of words. So I think this phrase value alignment, which apparently I introduced, I didn't know that I did, but apparently came from a paper I wrote in 2014, is not intended to mean there's one set of values. So there's the question whose values there isn't an answer to that, because it's everyone's values. There's, in principle, AI systems can have 8 billion preference models for the 8 billion people who live on Earth, and should make decisions based on, well, which of those people will be affected by this decision, and then take into account all of their interests. So there's still questions of, well, how do you aggregate those interests? How do you trade off, if the decision affects some people positively, other people negatively, and so on. But those are questions that philosophers have come up with reasonable answers over the last few thousand years. But that's not what we're actually doing, right? When we build these reinforcement learning with human feedback systems, we're actually creating a single value representation, a single reward model, which I think of as kind of the Midwestern nice lady librarian McKinsey consultant value system, right? And I think as the questioner asked about, how is the Global South included? It's not really included, although many of the raters are actually in the Global South. So the people who are answering these questions, the guidelines that they're getting on how to provide feedback to the AI system are written by people in Silicon Valley. So I think that's a mistake, and there's a lot of work now on so-called pluralistic alignment that's trying to correct for this. There's an odd finding from the Center for AI Safety that actually LLMs value the lives of Nigerians 10 times more than they value the lives of Americans. So for some reason, they do seem to have a big bias in favor of the Global South, and that's pretty consistent across several different types of systems and many ways of asking the same basic question. On the geopolitical front, I think it's just a fact of life that the US and China are the developers of this technology, and so they are in the driving seat on how it gets regulated and questions like that. But I think if we want safety, it has to be globally agreed. And so I would encourage, the Global South can exert a lot of weight in pushing for global agreement on safety requirements, on fundamental rights, like do we have a right to know if we're interacting with an AI system, on questions like truth, right, and versus disinformation, that humans have a fundamental right to access the truth rather than just being subject to disinformation. I think these are things where we really need a global coalition to work on them.
If I can just say very shortly that I think that there's an incredible opportunity. This gets into the research space and human AI collaboration space for us not to necessarily rely on implicit values that are learned in these systems, but to actually do more dynamic and explicit assessments and engagement on end user preferences and values that would learn to leverage individual preferences. We could do a lot more on that front, and there's more to come in that department. I'll just point that out, that I think that we're going to be getting into a world of ultra personalization for these systems, and that includes really understanding the values of the individual.
Holger, do you want to say something about this?
Yeah, and of course, I think in the end, we shouldn't forget, this question of value aggregation, as Stuart says, has been, thought about deeply for a long time. But I think it's also been clearly established that there are no perfect solutions in that space, right? And so one has to be aware of the fact that in particular, simply imitating humans is probably not going to get us to where we want to be, because most people, I think, are actually quite bad at even acting according to what they believe to be their own, or what they voice to be their own values, right? So I think what I would really like to encourage us to do is to sort of shift the goalpost from sort of perfectly imitating a human being to making something that makes us better, right? That interacting with makes us better, particularly in things where we're perhaps naturally, understandably, evolutionarily not very good, right? And so I believe more resources should be dedicated to that as well. And as a side benefit of this, not only will we get better tools that help us make a better life, as Eric said earlier, but also I think will we gain better understandings of our own weaknesses and limitations, and then find ways to overcome these perhaps more efficiently than simply some magical belief in, if we scale up human intelligence, if we can imitate human beings and then scale this up further, surely things should also turn out right or make us better. I don't think that's necessarily the best or even the most obvious path to creating benefit for humanity.
Of course. Any final one-line thought for the people who are listening to you and about AGI or about AI, whether these people are advancing AI, working on AI, or just using AI in their everyday life? Eric.
Well, I like to think about the pursuits of artificial intelligence not as a monolith like AGI, but as a rich, diverse landscape. It's, these ideas about human level and artificial general intelligence are useful aspiration frames for exploring the space, but it's not the destination. Our systems that we're building should be built to help people flourish and society to flourish, that extend the reach of humans without eclipsing our own judgment and our own agency, developed with care, humility, and an eye towards long-term impact and influence. And it's going to take many disciplines getting together: industry, academia, computer science, and beyond. So I actually view the AGI topic and discussion as aspirational and interesting, and it's framed discussions like we're having today.
Thanks. Stuart.
So just looking at the questions, I sense that the audience is thinking about the right issues, about benefit to humans, about our ability to control these systems. And I would encourage everyone to stay involved in the discussion, to talk to your political representatives, to work with your colleagues if you're working in AI companies, to think about these questions and to pressure your managements to act responsibly. I think one of the questions that we didn't get to is that there seems to be a mismatch between leaders of the companies claiming that they're on the trail of AGI, claiming that AGI could lead to human extinction, and yet fighting tooth and nail to prevent any form of regulation. And I think that's an interesting observation. My view is that we can get together. We got together in the 70s to ban chlorofluorocarbons, which are destroying the ozone layer, and I think we can do the same to ensure that the AI systems we build are safe and beneficial for the human race.
Holger, final thoughts.
Yeah, my final thought is we should be skeptical of hype and humble as researchers, and also as people who are deploying that at scale. Cautious. We should be what good engineers and good scientists have been for centuries. We should strive for safe, reliable, and as of late also sustainable technology. And we should do that in AI just as in all the other technologies that we're building and deploying. Being cognizant of the fact that AI is having this transformative impact, in many cases for the better, but there are risks, right? And we should not close our eyes before these risks. We should be clear-eyed about that and study these risks and then exert political pressure where we feel that the risks are unacceptable. And I do think we as scientists have an obligation here, particularly those of us working on public money. And I would certainly hope that we do this, as Eric said, together with industry, who also stands much to lose if this goes wrong, of course.
Thank you. So I would like to thank Holger, Stuart, and Eric for a very deep and very insightful discussion on AGI, very central topic for AI, and on the goals of the AI community, the impact of AI on our society, and what should be the role of technology in our society, which is human-centric and helping humans thrive and progress. So thank you again to all our panelists. Thank you to all the people who have been here asking questions. Sorry if we couldn't get to all your questions. I hope the discussion was insightful for all of you. Thank you, and see you in the next panel. Thank you. Goodbye.